All right, guys, good morning. We are going to be talking about a new kind of function today. We are going to be talking about exponential functions. All right, we've been learning all about linear equations over the last couple units. And guys, when we graphed linear equations, for example, if we did 2x plus 3, we graph a linear equation, it makes a straight line. Today we are going to change it up and we are going to be talking about exponential functions. And guys, the shape of exponential functions is very different, all right? And so the base exponential function here, I'll highlight this one for us, is going to be in this form. F of x equals ab to the x power. And so you notice exponential functions have our variable, that x, in the exponent. All right, guys, another way that you can see this written is instead of f of x, you could have y equals, and it can be a parentheses b to the x power. So you can see it with the parentheses or without the parentheses. I personally like to write it with the parentheses, but you can see it a couple different ways. And a couple important things here. Your a cannot equal 0, and your b cannot equal 1. Okay, and so your a value, this a right here in front, is going to be your y-intercept or your starting value, all right, at 0a. Your b value, which is the guy either inside the parentheses or it's the one that has the exponent, is known as your growth or decay factor. And if b is greater than 1, then it is going to be growth. And if your b is less than 1 but greater than 0, then it is going to be decay. All right, and we're going to talk a little bit about what this looks like. And then there's another important new thing in exponential functions called asymptotes. And so this is I know it sounds a little silly when I say it, but this is a horizontal asymptote, okay? Now guys, basically what this looks like, this is a horizontal line or a boundary line that your graph approaches and it normally does not cross. It cannot touch it. All right, guys, so in exponential functions, it does not, or you do not cross. That is super, super important. So if you have a horizontal asymptote, it does not cross that line. And that asymptote is a horizontal line, which means that it's a hoi. And so you write it as y equals a number. Okay, and it's not the a there, but it's y equals a number of whatever it does not cross. Okay, and so, so you can see it just like that there. And so what we will do is you guys will see this on, you guys are going to get a formula chart that looks a little different with exponential functions. And guys, these are so it's going to be a nice yellow one. And so guys, we have it written both ways. F of x equals a times b to the x. And guys, it is your y-intercept is your starting value, which is when the x equals 0. It's when it crosses that y-axis. And your b is your growth or decay factor. Now, I want to take a second to talk about this b really quick, okay? So the b, we're going to talk about this. It is a pattern, and it is the pattern of multiplication. So basically, guys, it is how the b changes. And so we're going to talk just a little bit about that in a second, but it's how that b changes. And or it's how your y values are changing. And so I just want to show you guys an example of what an exponential function looks like. Okay, so we're going to jump down here to 4 to the x power. All right, so I'm going to say 4 to the x power. And when you graph an exponential function, I want you to take a look at this. It goes up very, very rapidly. Okay, it starts off real, real low, and then it goes up super rapidly and super fast. Okay, so this is an example of an exponential function. All right, and so, and that is, in this case, it's going to be exponential growth. We're going to talk just a little bit about this. I'm going to rewrite this as my 4 to the x power right here. Okay, so because I like to write it with parentheses. And I think it's a little bit easier sometimes to identify your A and your B value. Okay, so in this case, my A value is the number in front of that, which is just a 1. So guys, we know that my y-intercept is going to need to be 0, 1. And then guys, my B value is this 4 right here. Okay, and so my B is equal to 4. Oops, you can't see that, sorry. So my B is equal to 4. So that means that this is going to be an example of growth. All right, I guess I can write growth, but because B is greater than 1. Okay, so it's growth because 4 is bigger than 1. Okay, now I've already graphed it here, but we're not just going to draw a random curve on the line. I actually want to get some good points here. So I'm going to say y equals 4 to the x, and then I'm going to go to my table. So I hit second table, and guys, I'm going to go ahead and take a look at some of these guys here. So I'm going to scroll up so it matches these. Interesting. So we see that looking at the points in my table, this first one is 0.0625, and then 0.25, 1, 4, and 16. Now guys, what I want you to notice here is before we graph our points over here on this line, guys, we knew that our y-intercept was 1 because the A value was 1. You can also see your y-intercept in the table as 1. So guys, my y-intercept here is 1. My y in the equation, it says that it's 1. My y-intercept in the table is 1. And then guys, I also want you guys to check this out. This is pretty cool. It is, you notice what we're doing each time to get to the next y value is we are saying 0.0625 times 4. And when I multiply by 4, that gets me to 0.25. And then 0.25 times 4 gets me to 1. 1 times 4. 1 times 4 gets me to 4, and 4 times 4 gets me to 16. So guys, that is also that pattern of multiplication. So we are multiplying by 4. In linear functions, we add the same number each time. In exponential functions, we multiply the same number each time. And so I'm going to go ahead and plot these points over here. Obviously, negative 0.625 is really hard to graph because it's really tiny. So my dots kind of look ridiculous. But then I'm doing 0, 1, 1, 4, 2, oh my gosh, 16. It's going to be like way off the graph. Okay, so if I was going to draw this, and guys, this is another thing I want to show you that's really cool. If I went to my table right here, you would see even though I go negative, my numbers actually never equal 0. That's 6.1 times 10 to the negative 5th. So it's just a really tiny little decimal. So guys, my numbers actually never equal 0, which means that this curve, if I'm going to graph it, it never actually touches 0. So let's see how that looks compared to my graph. Okay, mine's all right, but I graphed it there. And so that means, guys, that my horizontal asymptote here is y equals 0. So guys, my horizontal asymptote is going to be y equals 0. And so that means that my exponential curve right here never actually touches the x-axis, but it gets really, 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 really close. And I'm going to tell you guys right now, the default horizontal asymptote is 0. So guys, the default horizontal asymptote is y equals 0. So guys, right now, that's kind of like where you begin and where you start. And we'll talk about how that shifts in a little bit. Now we're going to talk about domain and range. So guys, my domain is going to be all of my x values, if you guys remember that. Ooh, I'm going to do it in black. So it's all my x values. And guys, you notice my x values go forever to the left. And ooh, even though they go up really fast, my x values are also going to go forever to the right. They just go They're going up, but because those little arrows, it's going to be going forever. So you can write it one of two ways: negative infinity all the way to positive infinity. Or, guys, what I like to write is all real numbers, okay? And the way that you can write that is with this little double R. So, guys, I'm going to start using this little symbol when I want to say all real numbers. You can still do negative infinity to positive infinity, but we're going to start saying all real numbers. And then my y values, my range, remember those are our possible y values. We have to look at what is the lowest possible y value. Well, guys, my y values never go below the asymptote, all right? So my y values are, they get really, really close to 0, but they never actually touch the asymptote. So it's 0 is less than y, but it goes up forever in the positive direction, so it's less than positive infinity. And so we have 0 is less than y, which is less than positive infinity. And then, guys, another way that we can, but one way that you'll start to see it is you're just going to start to see that the y is greater than 0. So that is kind of the way that we are going to have that in our little sign right here. And so that's how we're going to write this, is the y is greater than 0. All right, guys, so hopefully you guys are feeling good about this first one. Let's move on to the second one. All right, guys, now what we're going to do is we're going to take a look at this next one here. So we have f of x is equal to negative 1/2 to the x power. So, guys, before I even put it in my graph, I just want to talk about a couple little things right here. So we have a negative in front, and that's a negative 1. So, guys, that means that my y-intercept is going to be 0, negative 1. So that number in front, that a value, my a is equal to negative 1. And then, guys, my b value is the part inside that lovely little parentheses, and that is the 1/2. And so I'm going to actually put it down here. So, guys, my 1/2 means that this is going to be decay. So always look at your b value to decide if it's growth or decay. And so, guys, that means what we're doing here is we would be multiplying by 1/2 each time. So that's what my y value should be looking like, is right. We're going to be multiplying by 1/2. So let's see how this actually looks so we can identify our horizontal asymptote and all of our things here. So you can do it with the negative 1 or without the negative 1. And guys, I'm going to go ahead, instead of doing the little fancy fraction right here, when you do it, when you do the little fancy fraction, you're going to see your picture. But guys, when I go to my table of values, it gives me a bunch of fractions. So I'm actually going to go ahead and type in, because when I like to plot my points, I actually like them to be decimals. I feel like those are a little easier to plot. So I'm going to go ahead and do it like the flat fraction. And it looks the exact same, but now all my values in my table are decimals. So I'm going to go here and I'm going to say, okay, negative 2 is at negative 4. All right, and then we have negative 2, negative 1, and then negative 0.5, negative 0.25. Excellent, and if we kept going. So now I'm going to plot these points over here. So that's negative 2, negative 4, negative 1, negative 2, 0, negative 1, and then 0.5 and 0.25. All right. And so you'll notice my curve will kind of look like this here. All right. So I've graphed it. It looks pretty similar, all right, to the one that's there. That looks pretty okay. Yeah, they look pretty good. So now let's go ahead and fill in the rest of our information here. So once again, guys, my horizontal asymptote is that default. It starts right. It's that y is equal to 0. All right, guys, so that's that y is equal to 0. My domain is going to be, let's see here, my x values. They go forever to the left, forever to the right. So that means that my domain is all real numbers. And then, guys, my range are my y values. And, guys, this time, my y values are not greater than 0. My y values are less than 0. They are never equal to 0. because the asymptote means it can't touch it, but they are going to be less than 0. Now, one thing I want you guys to notice real quick is the ending behavior. Guys, the ending behavior of my growth functions go up, all right? They change really, really, really rapidly. So the ending behavior of growth goes up. The ending behavior of decay kind of flatlines. And so I like to think about, like, if your heart stops beating and you're hooked up to a bunch of monitors, it's like beep. And so it like flatlines, like it's like hooked up to a little heart monitor. Okay, so this is a good example of what decay looks like. All right, we're going to keep on moving along here. All right, we have another page. Let's turn that page. We're going to look at this top left example. So guys, when we look at this one right here, I like this one because once again, guys, my a value, my number in front here, is a 1, which means that my y-intercept would be a 1. All right, my b value is this number inside, so that is 3 over 2. And guys, 3 over 2 is greater than 1. It's 1.5. So that means that we are dealing with growth. So we know those two things without graphing anything at all. We know that it is the y-intercept, and we know this guy. So now I'm going to go ahead and graph it. It should look like growth. So I'm going to go ahead and do it that 3 over 2 to the x power. Notice your x is in the exponent. When I graph it, I want to see what it looks like. Okay, it is growth. Awesome. My ending behavior is that it's going up. We're going to take a look at this. Let's fill in our table values. Interesting. So that's going to be 0.444, sorry, and then 0.6667. And then we have a 1, 1.5, 2.25. And guys, what I want you to notice is every time here, we're actually multiplying by that 1.5, or that 3/2. We are multiplying by the 1.5 every single time to get to the next value. So that's what that growth factor means, is we're multiplying to get to the next one. Now if I actually go ahead and graph this line, let's go ahead and see here. So I'm going to start with 0, 1. I always start with my y-intercept. And then I'm going to do 1, 1.5, 2, 2.5. I'm going to get a couple more values, okay, for my table. 3, 3.75, 3, 3.75, and then 4 was around 5. All right, that helps me just have a little bit better curve. You don't have to do that. But guys, once again, once we look at our graph, we can see that there is a lovely horizontal asymptote right here. So the horizontal asymptote is right there at that default of y equals 0. My domain is all of my possible x values. They go forever to the left, forever to the right. So that's all real numbers. My range is my y values. And guys, what I want you to notice here is the y values are greater than your asymptote. So that means my y is greater than 0, because all of my y's are above. Now, one thing I want you guys to notice here is that that 0 is connected to your asymptote here. In this case, all of my values were greater than 0. Notice here we had y is greater than 0. That was connected to the asymptote from the first page. Here we had y was less than 0. This 0 is connected to that asymptote, because that asymptote is your boundary line. So it means you can't go above it or you can't go below it. In this case, we can't go below it. And so this one right here is a great example of exponential growth. All right, let's take a look at this one right here. F of x equals -2 times 3/2 to the x power. So guys, let's start off with our y-intercept, which would be 0, -2. That's our a value. All right, and then my b value is that 3/2. So b is again equals to 3/2. That's greater than 1, so that is growth. All right. We're going to go ahead and plug this guy in. Ooh, it's already basically there. -3/2. Ooh. All right. Make sure you type it in correctly. 3/2 to the x power. And then, guys, we are going to go ahead and let's see what it looks like first. Oh, what did I do wrong? Hey, you got to make that an exponent there. All right, 3/2 to the x power. If you type the wrong thing in, you will get the wrong answer. All right, so let's see here. Ooh, all right, so this looks very similar to this guy right here, except it is going, did I not, I also, y'all, I'm struggling. So that's supposed to be a -2. Let's graph it now. There we go, that's the actual right equation. So we have -2 times 3/2 to the x. Yikes. So guys, we notice this is still considered growth, even though it's going down, but the end behavior is a rapid change. So that means that it is still growth. So guys, and you notice by looking at this graph here, my horizontal asymptote is still going to be that default, that y = 0. All right, so let's go ahead and get some points here out of our table. So I'm going to go ahead and fill these in. So that's negative, I'm going to go this way. -0.0889, -1.33, -2, -3, -4.5. So you notice we're growing rapidly negative, which is kind of weird. But let's go ahead and we'll graph these little points. Oh, I should have started with my y-intercept. -2. There we go. And then 1, -3. And then 2, -4.5. So this is generally what, and I think that one's what, 6.75? There we go. So guys, this is generally what your curve is going to look like. We already talked about how that horizontal asymptote is that default right there at the y = 0. It is not going to go above the, that horizontal asymptote. So guys, that 0 is going to be connected to our range because the horizontal asymptote is always connected there. Our domain, our x values, forever to the left, forever to the right. So that's all real numbers. And guys, my range, it's not y is greater than 0, it is y is less than 0 because they are all under the line. So guys, a lot of these you can look at this. So one thing I want you to notice, these are both growth, all right? This is growth, and this is growth. This is just positive growth, and that's negative growth. These are still considered exponential growth functions because the b value is that 3/2. The b value is greater than 1, so these are both growth. All right, guys, I just want to make sure y'all understand. Those are both growth, even though one's going up and one's going down, okay? But the ending behavior is a rapid change, so it is considered growth. All right, we're going to do these last two because this is important because there's a little bit of a change. These are different because, guys, now it's not just the function. We also have a little thing with a subtraction here. So, guys, let's take a look here. Our first thing that we notice is that my a value is equal to 3. I'm going to hold off. I'm not going to put that in the y-intercept yet because I'm going to show you something that's a little bit weird. My b value is 2/3. That is less than 1, so that means it's decay. All right, y'all? And then and then we have this little extra number out here. All right, guys? So this guy right here, what this means is that our entire graph is being shifted down 4 units. So guys, remember how I said the horizontal asymptote, the default was y = 0? It's because we were adding nothing to those functions. It was +0, +0. So down here, our horizontal asymptote should be connected to that at -4. But guys, if my a value is that 3, then guys, my y-intercept is also going to be shifted down 4. So we would look at this and we'd say, okay, 3 minus 4, so that would give me a -1. So my y-intercept is actually going to be here at a -1. Now, our table is going to back this up. I wanted to show you it numerically, but guys, our table is also going to back this up here. So if we have 3 times 2/3 to the x, and I go to my graph here, you're going to look at this. Okay, this is decay, so it's ending in that flat line behavior. And guys, when I go to my table, we can look in this and we can say, okay, that's what, 6.75. Ooh, I'm going to go this way. and then 4.5, 3, oops, what did I do wrong? Oh my gosh, y'all, I forgot again. -4, I forgot to add the -4. Yikes. All right, so here we go. So it's not 6.75, it is 2.75. And then it is 0.5. It is -1, -2, -2.67. So guys, you'll notice your y-intercept is on this table as well. And guys, so you can always find your y-intercept on the table. You don't just have to look at the graph or the equation. You can also look at your y-intercept. And guys, it's because it took that a value, that 3, and we subtracted 4 to get that -1. So if we graphed these points over here, we would have 0, -1, 1, -2, and then 2.67. There we go. And guys, you will notice if we look at our graph here, it kind of curves like a little gently here. But guys, I want you to notice it's going to, the asymptote is actually going to be here at -4. All right, and you'll notice it gets really, really, really close to -4, but it never actually touches it. All right, -3.99, get really, really close, but it never actually touches -4. So guys, that means that my horizontal asymptote is actually going to be y equals -4. So my horizontal asymptote is right here. We're going to go up. There we go. And we're going to kind of bottom out there at the asymptote. So this is what my graph looks like here. Now once again, guys, my domain is my x values, which in this case is all real numbers, forever to the left, forever to the right. But my range is connected to that horizontal asymptote. So my y values are all above the asymptote because it's above the line. So that means it's greater than -4. All right, guys. So this was a pretty good review of our little functions here. We're going to do this last one. I want you guys to do this one on your own. All right, guys. I want you to go ahead and type this into your calculator. I want you to identify the a value. All right. I want you to identify the y-intercept. I want you to identify the horizontal asymptote, whether or not it's growth or decay, your domain, and your range. All right. So that is what I want you guys to do right now. All right, guys, so hopefully y'all were able to do that on your own. If you need to pause the video, guys. But here's the deal. Our a value was 1, but we were shifting up 3, so 1 plus 3 gave us that 4. We also recognize that to be true in our table here with the y-intercept. Our horizontal asymptote was that shift up. We were 0 plus 3, so it was y is equal to 3. That's a horizontal line. My b value was 1/2, which is less than 1, so it is decay. And then, guys, my domain is all real numbers, forever to the left, forever to the right. And my range is all of the values greater than 3. So, guys, what I want y'all to notice right here is both these ones on the bottom are considered decay because the ending behavior is that flat line. If the ending behavior is a flat line, it's decay. If the ending behavior is rapid change, it is growth. All right, so you can have 2 different kinds of growth and 2 different kinds of decay. So I hope that this helps for you guys to be able to identify and graph an exponential function. You can definitely use your calculator. It's going to be your best little buddy, especially getting those table values. And you'll notice the different things that we have there. All right, do y'all feel pretty good about this? I want y'all, we have one more page to do here today. So you're gonna need to pull up the next video.